How are you? I'm hoping that you are well. Welcome back to my YouTube channel. I'll be taking you on this video through Lab 3.3 on Ethernet link aggregation. So about this lab, as networks grow in scale, users require Ethernet backbone networks to provide higher bandwidth. They require higher bandwidth and availability. So in the past, the only way to increase bandwidth was to upgrade the network with high-speed line processing units, which is costly and inflexible. So in contrast, we have a technology called link aggregation, which increases bandwidth by bundling a group of physical ports into a single logical port without the need to upgrade hardware. In addition, link aggregation provides backup mechanisms, greatly improving network availability or link availability. Link aggregation has the following advantages: improving bandwidth, improving availability, and load balancing, all of which we learned during the theory class. So the objectives of this lab, by the end of it, you should be able to manually configure link aggregation. Also, you should be able to configure link aggregation in static LSCP mode, determine active links when you're using static LSCP mode, and also be able to configure some static LSCP features like load balancing and also preemption. Okay, so this is the scenario. In this lab activity, we have two links between S1 and S2 cannot be in the data forwarding state at the same time. Oh, I'm sorry. Let me just read that again. In the spanning tree lab activity, the two links between S1 and S2 cannot be in the data forwarding state at the same time. So what we mean here is in case we are using STP between these two switches, then maybe just this link G0010 will be on data forwarding state. Otherwise, as we all know, STP will block. If, for example, S1, let's assume that S1 is the root bridge, then S2 will block this interface and this interface. They'll be on alternates. So that is what happens when you're using STP. Now, to make full use of the bandwidth of the two links, you need to configure Ethernet link aggregation between S1 and S2. So that is what we want to do, to configure, to bundle up all this. To bundle up all these links into a single link like that. Logical link. Okay, so the configuration roadmap: number one, we will configure the link aggregation manually. Then we configure it using LSCP mode. Then we determine active links. Then we configure load balancing mode. So step number one involves the creation of the Ethernet trunk. So here we want to do manual link aggregation. So we'll create the trunk. Then step number two, no, still under step number one, we will configure the link aggregation mode of the trunk to be on what we call the manual load balancing mode. So the command is mode manual load balancing. After that, we are going to add the ports to the Ethernet trunk using that particular command, and also we will use the interface view on switch number 2 to add multiple ports to an Ethernet trunk using the trunk port command. After that, we will display the status of the Ethernet trunk. So let's just do that. I have already created the topology. You can also download it from the link on the description. Okay, so let's begin with S1. The command is interface. If I do tab for autocomplete, then we have that. If I do question mark here, you see you can be able to give it a number between 0 and 63. So we want to create interface ETH trunk 1 like that. So after we've done that, the command to display an Ethernet trunk is just that display ETH trunk, then the number ETH trunk 1. So we can see for now the number of up ports in the trunk is 0. The operation status of the Ethernet trunk is down. So we don't have any links under this particular Ethernet trunk. So to add links, as you can see in the background, we have interconnected S1 and S2 via G0010, G0011, and G0012. So you can either add them to the Ethernet trunk you've just created one by one, or you can bundle them up together like what we will do when we do switch 2. But let's go back to ETH trunk 1 so that we can be able to configure the mod. If I use the command mod and then question mark, then you have those two options. So we want manual question mark. So the next option under manual is load balance, so that the traffic can be equally shared on all the participating links. As we know, in manual load balancing mode, all the interfaces will forward data on an equal percentage. So let me quit. Then now I need to get into each of the interface. So for example, int G0/0/10. Then the command is ETH trunk, then the number of the trunk where you want to place it. So just like that. Then we can go. Okay, let me just quit so that I can do UTM. Okay. So we can go now to the next interface 11 there. Then I can use the history command to add it to ETH trunk 1. Then from here we can go to 12. I can use the history to add it to ETH trunk 1. So if I do quit, then I do display ETH trunk 1. Then we have a table that shows us that the number of up ports in the trunk, there are 3, their weight is equal 1, 1, 1, meaning they will be forwarding on load balancing mode. We can also see the status is up of each of the 3 interfaces, and the operating status of this particular Ethernet trunk is actually up. So let's move on. I want you to see how this table changes when we create the Ethernet trunk 1 on switch 2. So let's move on and do it. So UTM. Okay. So again, the command is interface ETH trunk, then the number, then the mod. We want to use manual load balance like that. Now the command to add multiple interfaces to the same Ethernet trunk is trunk port question mark. So the next thing you enter is the name of the interface. These switches only have gigabit Ethernet interfaces. Then question mark, then you enter the number. So for example, we want to add we want to add 10, then 2, 0, 0, 1, 2, like that. So you just do like that, then you press enter. like that. So this operation may take a few seconds. So that's how you add interfaces to multiple interfaces to an Ethernet trunk. If I do quit here, then for example, we go to int g0 stroke 0 stroke 10 and do display this, you indeed can confirm that this particular interface has been added on Ethernet trunk 1. Okay, so let's see how this table changes. If I do display that, enter. So before, what did we have? Oh, okay, not yet. Maybe it's taking a little time. Okay, takes about 30 seconds there. It should be able to show us the neighbor. So let me just confirm this, whether we have it here. Display ETH trunk 1. Okay, so this one is also up. This one is also up, ETH trunk 1. Okay, so let's see whether we can see the neighbor. Not yet. Not yet. Let's give it a few more seconds as we read these points. So note the following points when adding physical ports to an ETH trunk. Number one, ETH trunk contains a maximum of 8 member ports. So you are not supposed to add more than 8 interfaces to the same Ethernet trunk. Maximum should be 8. Also, Ethernet trunk cannot be added to another Ethernet trunk. You can only add an interface. Oh no, you cannot add an Ethernet trunk like ETH trunk 1, you add it to another ETH trunk. For example, you add ETH trunk 1 to ETH trunk 2. You cannot do that. The other thing is that an interface cannot be added to more than one Ethernet trunk. If you want to add an interface to a different Ethernet trunk, then you have to delete it from the original one first. To delete it, you use the undo command. Okay, then remote ports directly connected to the local Ethernet trunk member ports must also be added to an Ethernet trunk. That means that on switch 1 you've added G0010. G0010 on switch 1 is connected to G0010 on switch 2. So on switch 2 you must also add G0010 inside Ethernet trunk 1. Otherwise, the two ends cannot communicate. So you must add them on both sides. Also, both endpoints of an Ethernet trunk must use the same number of physical ports. Same number. So if you're adding 3 on switch 1 like we've done, you also add 3 on switch 2. So you cannot do 2, 3, or 1, 2. They have to be the same number. The port rate should also be the same. Like we've done, we've just added gigabit Ethernet. Gigabit Ethernet that are transmitting at 1000 megabits per second. So you should not add an Ethernet interface to an Ethernet trunk that has already gigabit Ethernet interfaces. The duplex modes should also match on both ends. Okay, so to display the status of the Ethernet trunk, the command is display ETH trunk. Display ETH trunk, which we have already used. So it gives you that. Okay, so let's move on. Yeah, I think that is okay. Let's move forward now to step number 2. So we want to change the mode. We want to configure link aggregation in LSCP mode. To do that, we want to delete the member ports from the Ethernet trunk. So to delete it, use the undo command, as we said earlier. Undo trunk port, then gigabit Ethernet, then the range, for example. So that's how you do that. So we want to do this. Let me copy. We want to do this so that we can let LSCP select the active links and the inactive links. So we can go to interface ETH1. That's the short for that. I can paste the command, enter. Can also go here, int ETH. So you have to go into the Ethernet trunk, then use the undo command, enter. So after you've done that, if you do display ETH1, then ETH1 has no interfaces. So that's how you confirm that indeed you have deleted display ETH1. Okay. So we now want to change the aggregation mode to LSCP. Now, LSCP mode is also commonly referred to as static LSCP mode. And in some switches like the one that we're using today in this lab, the command is not mode LSCP, but mode LSCP hyphen static, like that. So let's configure LSCP mode on both switches. You have to be on the Ethernet trunk, so ETH1, then mod question mark. So you can see that for us, we have to use LSCP static, enter. Then we do the same for switch 2. So interface Ethernet trunk number 1, mod question mark, we have LSCP static, enter, like that. So that's how you do it. Okay, so after we've done that, we can now add the ports to the Ethernet trunk again. So this time we use just the trunk port command. So we add them under the Ethernet trunk, view. So trunk port gigabit Ethernet 0/0/10 to 0/0/12. So we do the same here. Trunk port gigabit Ethernet 0/0/10 to 0/12, like that. Okay. So the next thing that we need to do is to display the status of the Ethernet trunk by using the display ETH_trunk command. So quit. I'll clear this, and then we have display ETH1. Okay. So you can see that when you're using LSCP mode, then the details of the partner is also displayed. Otherwise, what you're having here is just what we were seeing earlier. So, for example, we can see that the working mode is, we didn't look at it earlier, but if we could have looked at this earlier, then it should have read manual, but now it's reading static, meaning it's static LSCP mode. We can also see the system priority is the default priority 32,768, and the MAC address or system ID of this particular switch is that one. We can also see that the maximum active link number is 8, list is 2, the operating status is 1, the number of interfaces that we've added in this trunk is 3. We can also see the individual interface status. Is it selected or unselected? So selected means it's forwarding data. So all of them in this case have been selected. All of them have been selected. So on the other end, you also see the interface for the other switches, the system priority for that switch, and the system ID, which is actually the MAC address. You also see the port priority, by the way, here. Port priority default is 32768, and also the port number. Okay. So now, in step number 3, it says in normal cases, only 11, 12 need to be in the forwarding state. Then 10 is used as the backup. So that is what we want to do. So when the number of active ports falls below 2, the Ethernet trunk is shut down. So that is what we want to configure. We want to make sure that only 11 and 12 are forwarding. This one is inactive and selected, so that this one acts as a backup. We also want to configure so that the least number of active ports for the Ethernet trunk to work is 2. If it falls below 2, then the Ethernet trunk, we want it to be shut down. So in order to do that, we want to configure S1 with a higher priority. So to configure it with a higher LSCP priority, we configure it with a lower value of LSCP using that command on system view. After that, we are going to make this interface the backup interface by assigning it a higher value of LSCP priority. The default is 32,768, but we want to configure it with this so that it can be inactive. So let's do that. Okay. So the first thing is to use the command lscp priority. So the priority can be anything between that. So we want to give it 100 so that we ensure that it's a lower priority. Let me just do display ETH1. So you can see as it is right now, this is our system priority, 32,768. Now, if we use the command lscp priority 100 and use the same command, display Ethernet, we can see that now our system priority has changed to 100. Okay, so for gigabit Ethernet, this one, we can see that the port priority here is 32,768. So we want to change that to 40,000. So int g0/0/100. Then we use the command lscp priority. We give it 40,000. Enter like that. Then I can quit. Then I can, after that, I can do display that, and now we can see that the priority has changed. The port priority for that interface has changed to 40,000. Now, when we do this, we expect that maybe this now will be unselected. This interface will be unselected, but not yet there. There are a few things that we still have to do in order for this interface to be an inactive link. Okay. So what we've just done, the actor will be elected. So how is that done? The system priority field is compared. Default priority is that. Lower value indicates higher priority. So the endpoint with a higher priority is elected as the LSCP actor. So as it is now, S1 here is our LSCP actor. LACP actor, link aggregation control protocol actor. Mm-hmm. Okay. If there is a tie in the priority, the endpoint with a smaller MAC address becomes the actor. So uh, uh, remember that. Okay. So now we want to set the upper and lower thresholds of active ports. Upper and lower thresholds. Uh, so these now will determine the number of active links. So the command is maximum active link number. So if we choose 2 and we have 3 links, then only 2 are going to be active. The rest are going to be backups. The other command here is least active link number. If we choose 2, if uh, 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 the physical interfaces that are bundled into the Ethernet trunk, if they fall below 2, then the Ethernet trunk is shut down. So that is what those two commands are used for. After that, we will enable preemption. By default, preemption is disabled. So preemption means if a faulty link, for example, is recovered and has a higher priority than the backup link, then the recovered link can restore the active status if preemption is enabled. So we want to enable that so that we can be able to see the difference. So let's do exactly that. So we can just do that on the actor, for example. So we go to interface it trunk1, then the command is maximum link maximum active link number. We make it 2, then least active link number. We also make it 2, like that. So now we can quit. Before we enable preemption, let's just do display ETH1. So you can already see that because we have said that the maximum active link number here is 2, then one of the links is going to be inactive. So that link is the one that has a lower priority, the one that has a higher priority value. So that's why G0010 is now unselect. The status is unselect, meaning it's inactive. It will not be able to forward data. It will act as the backup. Okay, so let's go ahead. Let's go ahead and ETH1. Let's go ahead and configure the LSCP, enable LSCP preempt. So LSCP preempt enable, like that. So once we've done that, we can be able to display uh, changes in our network. So for example, we want to shut down G0012 to simulate a link fault and see how our ETH trunk 1 is going to change. So what we want to do is to shut down this interface, this one. We shut down this interface on S1 to see if this one is going to be reactivated. So let's do that. So from here we can also go into 12, just like that, and we use the command shut. So if we do that and do display ETH1, then you can see that G0010 has been selected again. It has been reactivated. And this one, because we've shut it down, it's unselect. So it's not forwarding data. Okay. So we've shut down this. This has been reactivated. Okay. So the next thing we want to do is to shut down 11. So we want to shut down 11 to simulate a link fault. Remember, when we shut down 11, it's going to make this particular Ethernet trunk to have less than 2 less than two interfaces or interfaces. So it means that now this Ethernet trunk has to be shut down. So let's do that. G0 stroke 0 stroke 11. Then we use the command shut or shut down, quit. Now, if I do display, uh, ETH1, you can see that even though we've not disabled this one, 10, but all of them, the status is unselect. All of them, the status is unselect. Because we have shut down 11 and 12, so it has less than 2. Remember, this is the command we used, list active link number. Let me just show you that. This one. So if we go below 2, then we shut down everything. And indeed, you can see that the operate status is down. Okay. So the other thing we need to do is to change the load balancing mode on LSCP. So enable the ports that we had disabled. So that's what we need to begin with. Then we need to wait for about 30 seconds and check the status of ETH trunk 1. So let's do that. So int gigabit Ethernet 0 stroke 0 stroke 11 undo shut. Then we go to 12 undo shut. Okay, quit. So if we check ETH trunk 1 immediately, oh, that was fast. Okay. Okay. So you can see this one is still unselect. 12 is still unselected. 12 is still unselect, even though it has a better priority than this one. Remember, we enabled preemption, but now that preemption takes about 30 seconds before it happens. So if we check again, I don't know if 30 seconds has elapsed. Yes. So if we check again, you can see that now this one with a lower priority has been unselected and this one has been selected. So that's what happens when you enable LSCP preemption. By default, it is disabled. By default, it's disabled. Okay, so now we want to change the load balancing mode of the Ethernet trunk. To do that, we use the command load balance DST-IP on the Ethernet trunk view. So let's do that. So int eth1, then we use that command load balance DST-IP. Now let me just do question mark here. Okay, so you can load balance according to the destination IP or according to the destination MAC address. So that means that all frames that have the same destination MAC address are forwarded via the same physical links. Or you can load balance based on this. Or you can combine. You can combine source and destination IP address forwarded along the same, or according to the source or destination MAC address. You can combine like that. Okay, or according to source IP alone, or according to source MAC alone. So when we say DST IP, you now understand what that means. Okay, now I thought this was important to ensure proper load balancing between physical links of an Ethernet trunk and avoid link congestion. Use the load balance command to set the load balancing mode of the Ethernet trunk. So load balancing is valid only for outgoing traffic. Therefore, the load balancing modes for the ports at both ends can be different. So the load balancing mode on switch 1 and the load balancing mode on switch 2 can be different. For one, you can use DST-IP. For the other, maybe use DST-MAC. But of course, as we learned in the theory topic, you know when to use which particular mode. So always ensure that you do that. So ladies and gentlemen, thank you very much for your time and for listening to me. I hope you've learned how to configure Ethernet trunks both in manual mode and static LSCP mode. Asanteni sana. Kwaherini kwa sasa. Bye bye.